Hi, and welcome to the video where I'm going to show you how to conduct a simple linear regression using SPSS. So I'm going to open up SPSS. So I have my data view ready to input data, and I'm going to pull up my scenario now. Okay, so for this particular example, we're going to say, according to a recent Gallup poll, the 48% of U.S. adults who drink soda reportedly average 2.6 glasses of soda each day. Fictitious data are provided for the following variables with the operational definitions. So we have the age of participants and then the number of glasses of soda per day. We want to use this data to test whether we can predict someone's average daily consumption of sodas based on their age. Okay, so we have two variables. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. So we have 10 ages and how many glasses of soda they drink per day. So we need to get this into SPSS. I usually like to make sure that in SPSS I'm in data view, and I like to copy and paste the data directly over to just minimize likelihood of having human error, right? So I don't copy these because they have the words. You only want numbers in data view. So I'm just going to start at the very top, come down, highlight all just my numbers. I'm going to hit Control C, or you could right click and do copy. And then when you get into data view, make sure you're in one in the very top column, and I'm going to right click and click paste, and there's my data. Okay, so you see up here, it's just variable 1, variable 2. That's not very descriptive, so I'm going to go to variable view and name my data. So the first one was age, and the other one was number of drinks, soda, whatever you want to name it. And then for a scale of measurement, we're going to go ahead and hit each as scale. So this is in variable view. Each row is a variable. So we have age up here. Make sure it always says numeric. And drinks is also numeric and scale. And then in data view, you have your actual numbers. If the copy and paste doesn't work, sometimes you do just have to enter them one by one. But make sure you enter them in the exact same order. So row 1 is one participant. They were 22 years old and they report 4 drinks per day. This is an 18-year-old who reported 3 drinks per day. So with linear regression and correlation, it's very important that each row is a single participant. Okay, so we're ready to run our simple linear regression. So what we're going to do in SPSS, we're going to go to Analyze, Regression, and Linear. Since we are trying to see if we can predict someone's average daily consumption. So we want to see if we can predict the drinks. So that would be your dependent variable. And so your independent variable is age. So when you're doing a simple linear regression, you do have to read the scenario and see what you're trying to predict. That's going to be the dependent variable. And then the other variable would be your independent variable, or what, the predictor. Okay, so we're going to go to Analyze and then Regression, Linear. And here we have age is our independent because we're trying to predict how many drinks they have. So if I did that too fast, you just click on each variable you want. So like right now, I click on drinks and I click the arrow and moves it over here. So we got drinks and age. On statistics, go ahead and do estimates, confidence intervals, model, fit, R-squared, change, and descriptives, and hit continue. And that should be all we need for that one. All right, so then we'll just click OK. And here is our output. So oh no, it went away. Sorry, I was going to try something new, but that's fine. All right, so we have our descriptive statistics for our drinks and age, just the average number of drinks, the average age of the people with their variability, standard deviation. Our correlation, we'll notice here it said negative 0.695. Here is showing us what we entered, so we were trying to be able to predict the number of drinks someone had based on their age. And here's our model summary. We're going to look at this for the R-squared. That lets you know how much you can predict based on one variable given the other. So we would just transform this to a percentage. So instead of 0.483, it would be 48.3%, which is pretty good. All right, and then the last thing we'd look on this would be the ANOVA. This is going to be our statistical output, whether our hypothesis is supported or not. And what we want to look at first is that sig column. Remember, our alpha value is usually 0.05. So if that sig value is less than 0.05, then we reject the null hypothesis and we conclude there is a statistically significant difference. So since our sig value is 0.026, we are going to conclude that there is a significant relationship here. We can predict how many sodas a person drinks based on their age. It's a negative relationship. We found that out because of our negative correlation up above. So that's going to let us know that the older someone is, the fewer the sodas they drink. We will also need to report our degrees of freedom and our F change. So I'm going to just double click on this ANOVA to pull it up in the chart editor, just to kind of highlight some of the numbers we're going to be getting. So we will be using those, the 1 and the 8 to report, as well as the F and the sig value. So we'll be using those. We'll be using the R squared to report. And then we'll also have to use our correlation way up here, just the correlation coefficient of negative 0.65 or 695. And then also we have these coefficients down here. This is what we would use to be able to report our regression equation. So we would look at the unstandardized coefficients, this 6.754 and the negative 0.174. So we'll be using those values. And last thing I'm going to go ahead and do before we show you how to write this up is I will create the graph. So we would use a scatter plot and we're going to add the regression equation to it. So we're going to go to graphs, simple scatter dot, and so the simple scatter is right here. Now what happens is we do want to put what we're trying to predict, so the drinks on the y-axis and age on the x-axis. So your dependent variable does need to go on the y-axis. So it's pretty important to do that. Okay, let me click OK. And here is our scatter plot. It's not quite an APA, so I'm going to double click on this, and I need to go to options, hide grid lines, and then also this age should not be bold. So if I click on it, I can go up here and unbold it. The drinks might not be very telling. You might want a longer. So you just click on the axis titles, but remember to use title case. So drinks per day. You can write sodas per day might be more informative. And the last thing we need to do is get a regression equation. So just make sure the linear is selected and click close, and then X out. And I know it hides it from you. I don't know why it likes to do that. But then here is our regression equation. We can see that this 6.75 minus 0.17x is exactly what we would get up here. We're getting a minus 0.174 because it's a negative. It would be a plus if there was not a negative sign here, but that's your regression equation. Okay, so we're going to use all of this to write up the results. All right, so I've already started the write-up. I just want to show you where I got this data from. So it says a linear regression analysis was conducted to evaluate whether someone's age can be used to predict their average daily consumption of sodas. See figure 1. So in parentheses it says see figure 1. You notice the F is capitalized. This is considered a call out using APA professional conventions. All right, it was significant. And then you'll notice this right here that I'm highlighting, the F1, 8 equals 7.47. I'm going to round to 2 decimal places. And then you don't round your p-value, so p equals 0.026. Let me show you where I got those numbers. That's going to be right up here in that ANOVA table. So this is correlating to this table right over here where I have those highlighted. Okay, the regression equation for predicting soda consumption is y prime equals negative 0.174x plus 6.754. So that is where we got it from these coefficients, that first column. You'll notice it's organized differently than the one provided here. Either way, it's fine. They're saying the exact same thing. All right, now we're here. The correlation between age and daily consumption is negative 0.695. That was in the correlations up here, the negative 0.695. And then lastly, it says approximately 48.3% of the variance in number of sodas consumed daily is accounted for by its linear relationship with age. That 48.3% is the R squared. So 0.483, we convert that to a percentage to be 48.3. Okay, now we have this. I've already typed in, this is how I highly recommend you do it. You type the word figure 1, it's bolded, and then double space underneath it you have the title of your figure. It's in title case. So linear regression between age and daily soda consumption. That's, yep. And then underneath the figure we'll have a note that says the regression was significant. All right, so now we just need to go, and this is, we've already modified it to be an APA. I'm just going to right click and copy it as an image, and that will allow me to go right in between my title and my note, and right click and paste it. And then I like pasting it as an image because you can just make it bigger or smaller and it maintains the ability to see what it says. And there is your APA write-up for a simple linear regression. All right, thanks.